Today we are starting chapter 3. We will do the first 4 sections of chapter 3. Then we'll stop, review for a couple days, and we will take a quiz at some point next week. So today is a lot of vocabulary terms. It's just sort of the basic relationships between lines. So first word. You probably already have this in your notes, I think, somewhere. So if you want to write it down again, that's great. If you know where it is, or if you already know this definition, that's fine too. I'll leave this one up to you. So I'll give you time to write it if you want it. If you know you already have it and you already know what the definition is, you can say no thanks, all right? But parallel lines are 2 lines that lie in the same plane and they do not intersect. I do want you to write this. That's how you can show in symbols that 2 lines are parallel. And then in a diagram, I also want you to draw this. The bold arrows, that's a way that we can show that lines are parallel. So I don't really think I'd write like to indicate that line R and line S are parallel. I would just write the part I put in the box. That's the symbol for parallel. And then in a diagram, the bold arrows on top of the lines, these guys, that's a way to show in a diagram that they're parallel. So parallel lines never intersect, but they do lie in the same plane. I always think of parallel lines like the side of a train track, right? It just keeps going and going and going. Bold arrows. Once again, this might be something you already have in your notes. If you can locate it, great. Or if you already know this and you don't want to waste time writing it, that's fine too. If you want to have it, I'll give you some time. Perpendicular lines are 2 lines that intersect to form right angles. You can show that 2 lines are perpendicular. This guy is new. I do want you to have this. And if you didn't write the definition, then like put an arrow towards it and say like perpendicular lines. It's like an upside down capital T. That means that line R is perpendicular to line S. And we've used this a lot already. The box looks like a little box inside of an angle. That means that it's a right angle. Well, perpendicular lines are 2 lines that intersect to form right angles. So if you see the right angle box, now you know the lines are perpendicular. You can go ahead and just, I think you could draw that. I'll give you a second. Main things you want to put are labels on the lines. Make sure you include the box and make sure you include these bold arrows. So our options for answers here are parallel, perpendicular, or neither. So on that first one, let me find my highlighter. The first one, line T, this guy, and line U, this guy. So are those parallel, perpendicular, or neither? They make a right angle, the 2 that I just highlighted in red? That's a neither. Those aren't doing anything special. So we would write neither. All right, I'll change my color to blue. Line S, that's this one. And line T, that's this one. Those are parallel. They're marked with the little double arrow, the bold arrow things that show parallel. So you can write the word parallel, or you now know a symbol for parallel. So you could just write the symbol if you want. All right, and we'll go green on this last one. So line R, that's this guy right here. And line U, yes, they're the ones that make the little box, the right angle box. So those are perpendicular. And once again, we know a symbol for that. So if you just want to put the symbol now, you can. If you're not comfortable with the symbols, you can write the word perpendicular. That's one of the reasons I like geometry, is because there seems to be like it's like another language in writing that, you know, you can shorten things up a lot if you learn the symbols. But in written form, yes.
R and U is what?
RU is perpendicular because it makes the right angle. But I use the symbol first, the upside down like capital T thing. That means perpendicular, or you can just write the word perpendicular. So if two lines never intersect, they're automatically parallel. No, there's another relationship we learned. Does anyone remember what it's called? They don't intersect, but they're not parallel. Not perpendicular, because they're not going to intersect. What about like the... Yes, lines on different planes. I was just trying to find an example. So like that strip over there, that like up above the chalkboard, and like this over here where the chalk is sitting. Those aren't going to intersect, but they're not parallel either. It's because they're on different planes, okay? So this is just saying that, remember, to be parallel, they have to not intersect, but also not be on the same, or also be on the same plane and not intersect. This is what it's called when they don't intersect, but they're not on the same plane. These are skew lines. Once again, this is one you do have in your notes somewhere, but this is one that everyone always forgets, so I do want you to write this one down.
Was we supposed to write the other side?
No, you didn't need to write that down. So skew lines are lines that do not lie on the same plane and they do not intersect. So if you're looking at a tissue box, like one of the corners going up and down on the back of the box, and then the one going like side to side on the front of the box, those would be an example of skew lines. I also like to think of, and we talked about this the last time we did skew lines, highway overpasses, where it's like one's going below the other one's way up in the air. They're not intersecting, but they're not running side by side either. Skew lines. Lines that do not lie in the same plane and do not intersect. I am not going to make you draw this because I think that this is one where it would just kind of get lost in the diagram. It's a challenging diagram to process anyway. I think drawing it might make it worse. So what we're looking at here is a plane. Here's our plane, right? Looks like a piece of paper, like a slanted floor tile. These two lines are on the plane, and this line is going through the plane. So if you think of like my iPad as the plane, with the lines B and C would be laying on the iPad, and then that line A is like a pen or something, like piercing through it. Okay? So although it looks like A and C, for example, are intersecting, doesn't it? They're not. You have to think of A as like above C and then shooting through the plane through B. It does not touch C. Okay? Does that make sense? It's kind of hard to visualize. But determine if the lines are skew. So are A and B skew? No, because they intersect. Are B and C skew? They're not skew because they're on the same plane. They're parallel. They can't be parallel and skew. This is no. The only skew lines are A and C because of what I just described. A is like closer to us than C is. C is back in the back of the plane, laying flat. A is closer to us, going through the plane. So these are skew, yes. If you want to write these, that's fine. If you didn't, it's not a big deal either. This one I do want you to write because we don't have this anywhere in our notes yet. Parallel planes. Those are two planes that do not intersect. Just the definition is fine. You don't need to write the rest. But it is helpful to look at some examples. An example would be like the floor and the ceiling. They're parallel planes. They don't intersect. Two planes that sort of hover on top of each other. I always like to think of like an Oreo cookie. Like the top and the bottom, they don't intersect. I mean, once you bite into them, maybe a little bit. But you got that cream filling in the middle, sort of keeping them the same distance away from one another. Or like the bread on a big club sandwich, you know. A lot of food examples of this one. All right, I believe this is the last one. So go ahead and this guy. So this is when a line is perpendicular to a plane. So a line that's perpendicular to a plane is a line that intersects the plane at a point and that is perpendicular to every line on the plane that it intersects. Here is a good real life example. If you have a flagpole, the ground is the plane. So everywhere that the flagpole meets the ground is a 90-degree angle. There's just tons, infinitely many 90-degree angles formed. Again, like my iPad with a pencil sticking right out of it. That's a line that's perpendicular to a plane. So this is what it would look like on a diagram. So if the red line is perpendicular to the plane, then any line that you would draw on the plane through the red line would also be perpendicular. So, for example, like right angle, right angle, right angle, right angle. So the flagpole is a great example, but this is what it would actually look like in a diagram, okay? So here is example 3. Once again, I think it would be most beneficial just to watch. I think by the time you draw the diagram, it's not going to make much sense anyway. So part A says, name a plane that appears parallel to plane P. That's a tongue twister. So I'm going to highlight plane P so we all know what we're talking about. Plane P is this one right here. So the one that's parallel to that one is which one? Plane Q. Good. All right. B, name a line that is perpendicular to plane R. So I'm going to get rid of this highlight. Plane R is the flat white plane. So do you see how line M is coming right down, making a right angle? So yes, you are absolutely correct. It is line M. And then number 3, so I just highlighted line M in gray so you can see that one. Name a line that's skewed to line M. Line N, it's way over here, not going the same direction, not on the same plane, never going to intersect. Perfect. Line N. What questions do you have? Once again, you don't need to try to draw this. This diagram does appear a lot though on quizzes and tests and stuff. It's basically just a ramp. Like you have a flat rectangle, a rectangle going the other way, they're perpendicular, and then a ramp. So if you imagine like a bike ramp, like woo, okay? Name a plane that appears to be parallel to plane ABC. ABC is already highlighted in the gray. So what plane looks like it's parallel to this one? Plane DEF. Good. Just the other side of the ramp. All right. Name a plane that's perpendicular to plane ABD. So ABD is this one back here. So which plane looks like it's perpendicular to that plane? Well, I see the little box down here, right? So the plane that's perpendicular would be which one? Think of a ramp. Like if you were making a ramp, that's like the back of the ramp. Which one would make a right angle with that? EFC, yeah. The bottom of the ramp, right? Which one would make a right angle with, if you're looking at, like thinking of a ramp, the side that's going straight up and down, the one that would make the right angle would be the one that it's laying on top of, like the flat one. So yeah, you said EFC, that works. Any 3 letters. Plane, E, F, C. You could call it like AEC or AEF, just 3 letters from the bottom. Good. Name a line that's perpendicular to plane AEC. AEC is the bottom one. So the one we just talked about in gray down here. Now we want a line perpendicular. So here was the little right angle box. So that line is what? Yep, line AB. Good. And it'll be a little easier when you have the diagram and you can write on it than me just like pointing to it. What line is skewed to BC? Give me a second to clean this up. We got a lot going on over here. BC. So BC would be this one. What's a line that's skewed to that?
BEF.
B. Well, they would intersect at B. So you're on the right track, but they would still intersect. If it has a B in it, it's going to intersect at
EF.
B. EF is good. Yes, they're not going to intersect. They're not on the same level. They're going in different directions.
What about DE?
EF. DE would work too. AE would work. Yep. Very good. And then now I want a line that's parallel to BC. DF. Good. I think the hardest part, like I've said a few times, is just visualizing this in 3 dimension. You can't, it kind of looks like everything's plop right on top of itself now. You got to actually think of like, what does this look like in real life? So I always think kind of like a bike ramp, you know. All right, questions?
No.
All right, what did we learn about today?
Not breaking relationships.
Yeah, it was all about lines and relationships. All right, here comes your homework.